and gentlemen, what we're going to take a look at today is, Stu and Jackson, stop, turn around please. Like I said, how we're going to solving equations when the degree is 3 or larger and factoring or grouping doesn't work. So there's some things you want to look at in the equation to kind of help guide you when you start the process. First of all, we talked about degree of a polynomial. Refresh my memory. What is the degree of a polynomial? How do you know what the degree is? It's the largest, what? Exponent in the equation. If it's factored form, if it's all multiplied out, it's factored form, you have to add up the degrees of those factors, remember. So what you're first going to do is you're going to take a look at your equation and figure out how many solutions am I actually looking for. Remember, you're going to use the degree of the polynomial to determine the the actual number of real zeros. So a theorem that you talked about last year in Algebra 2, a polynomial function cannot have any more real zeros than its degree. So in other words, the degree is equal to the maximum number of zeros. So if you have, let's say, a 6th degree polynomial function, you can have no more than 6 solutions. If you have a 20th degree polynomial function, you can have no more than 20 solutions. So we know that the turning points, remember you can discover the turning points by taking the degree minus 1, but you can also look at the degree to help you discover how many actual solutions there's going to be to the equation. Another thing you're going to use is the rational zero test. So if the polynomial has real coefficients, then use the rational zero test to identify your potential candidates for the zeros. So this is where some of you may not have seen this back last year in Algebra 2, the rational zero test. What you do is, I call it the P over Q test. So what is P? P is the coefficients. The coefficients is actually, I'm sorry, I have that backwards. P is your constant term. So the term that does not have a variable, that's your P. Q is the coefficient of the highest term, meaning that's the coefficient of the variable with the largest exponent. You take all your possible combinations, you take your factors of P and you divide it by the factors of Q. And again, they must be real coefficients, no imaginaries. We're only dealing with reals. We're not going to get into imaginaries. I know it breaks your heart. We're not going to deal with solutions of i's anymore. So for example, list the potential. I'm not asking you to solve. I'm just asking you to list the potential rational zeros of this particular equation. First of all, what's my constant term in this? 2. My constant is 2. So that's my P. So P is equal to 2. So now, list all the factors of 2. What are your factors of 2? When I say factors, those are the numbers multiplied together to give you 2. What numbers multiplied together give you 2? 1 and 2. There's another combination too. Can't you say -1 and -2? So when I say your factors, you have to consider both the positive and the negative. So plus or minus 1, plus or minus 2. So now, Q is the coefficient of the variable with the largest exponent. So what is the coefficient of the variable with the largest exponent? 6. So I'm going to do the same thing. List all the factors of 6. So what numbers multiplied together give me 6? Plus or minus 1, plus or minus 6, plus or minus 2, plus or minus 3. So any questions on how I listed? Now what you're going to do is you're going to make a whole bunch of fractions. So this is my potentials. So I'm going to make a long list. And in that list are going to contain the only possible real zeros. And if this equation has any real zeros, it can't be any other number other than the list I'm going to create. So what you're going to do is, first of all, take your factors of P. So start with 1. I'm going to take plus or minus 1. Over. Now I'm going to take this 1 and place it over each individual factor of Q. So plus or minus 1 over 1, plus or minus 1 over 6, plus or minus 1 over 2, plus or minus 1 over 3. So I start with this very first factor of 2, which is 1, and I just make a whole bunch of fractions, 1 over 1, 1 over 6, 1 over 2, and 1 over 3. Any questions on how I made these fractions? Now I'm going to do the same thing for the other factor of 2. So I'm going to take plus or minus 2 over 1. Now, if I make another fraction 2 over 6, doesn't 2 over 6 reduce to 1/3? Yeah, so I don't need to list that number twice. 2 over 2, doesn't 2 over 2 simplify to 1, which is already in my list? And then plus or minus 2 over 3. So this is your list of potential rational zeros. So like I mentioned, my polynomial cannot have any other real zeros other than what's in this list. Okay? So any questions on how I make the list of possible rational zeros? How many of you have seen this before? A couple of you have seen it. I think honors may do it. I think regular does not. All right? So any questions on your possible rational zero tests? Like I said, this is where that little bit of old comes in with a little bit of new. So now this is where, from your list, you make a possibility of your zeros based on the graph and the list of potential zeros. You're going to test each potential real zero by using synthetic division.
Conjecture.
So you'll use synthetic division in that list of possible rational zeros to actually start finding your zeros. Each time a zero is found, thus a solution is found, we're going to repeat step 5b on what we call the depressed equation. And we use factoring techniques. So the idea is what we want to do. When I say the depressed equation, once I find a zero, I can start the factoring process. Get it down to a factored form, down to a quadratic equation, so then I can use quadratic formula completing the square. Again, the goal is to rewrite this in factored form until it is to a degree of 2. That's your goal. You've got to get it down to a degree of 2, because that's when you can use completing the square and quadratic formula if you have irrational solutions. Remember, this is only going to find your rational solutions. Irrationals, you've got to get it down to completing the square or using quadratic formula. Okay? So this is where some of these other theorems from Algebra 2 talked about. If you have a polynomial function and you're dividing it by x minus c, to be a factor, the remainder has to be 0. So find the remainder, again, if you have this polynomial divided by x minus 3. Can I use synthetic division? Can I use synthetic division? Yes. So let's go ahead. If you really love long division, you can. What's going to go in front of the rectangle? Again, I'm dividing by x minus 3, so what's the 0 that goes in the front? 3. So I have 1, negative 4, 2, negative 5. Remember, you always bring down your very first leading coefficient. Multiply on the outside. 3 times 1 is 3. Add on the inside. Negative 4 plus 3 is a negative 1. 3 times negative 1 is negative 3. 2 plus negative 3 is negative 1. 3 times negative 1 is negative 3. Negative 5 plus negative 3 is negative 8. So what is your remainder? Your remainder is what? So now let me ask you this. Is x minus 3 a factor? No. So x minus 3 is not a factor. It can only be a factor if the remainder is 0. So I know then that 3 is not going to be a solution to this particular equation. Okay? So we'll talk about some more of that in a minute. So any questions how you can find the remainder and we know whether or not it's a factor? So like I just mentioned, kind of we know that it has a factor if and only if the remainder is equal to 0. This f of k is equal to 0. This is talking about your remainder. Your remainder has to be equal to 0 in order for it to be a factor. So is x minus 10 a factor of 2x to the third minus 14x squared minus 56 minus 40? Can I use synthetic division? Yes. What's the 0 that comes from x minus 10? The 0 that comes from x minus 10 is what? What goes in front of the synthetic division? 10. So I have 2, negative 14, negative 56, negative 40. Bring down your very first coefficient and do the synthetic division process.
Okay.
10 times 2 is 20. Negative 14 plus 20 is 6. 10 times 6 is 60. Negative 56 plus 60 is 4. 10 times 4 is 40. Negative 40 plus 40 is 40. So what's the remainder? Remainder is 0. So answer the question now. Is x minus 10 a factor? Yes. Again, it's a factor because your remainder is 0. You guys go ahead and do B for me. Tell me whether or not x plus 2 is a factor. All right, so now, ladies and gentlemen, if you know what, yeah, Emma, go ahead. Which number do you have different at the bottom?
I see that it starts at 19. I thought 19.
19 for what? Oh! Still going to be no, but yeah. So that's going to be, I can't do my multiplication today. So that's going to be negative 28. Sorry about that. Thank you. Okay, so ladies and gentlemen, shh. If you know 1, 0, that's kind of your springboard to help getting you started in the factoring process. You still always look, if I ask you to factor, you still go back to your old stuff. Still look to see if grouping works. Is it a difference of squares, is cubes? Don't forget about all the other. Don't make the problems longer than necessary. If one of your old factoring techniques work, use it. Grouping, all that other stuff. Unfortunately, ladies and gentlemen, grouping is not going to work here. I don't think it does. But anyway, I'm giving you a 0, which is negative 2. So what I want to do is I want to start the factoring process. If you know a 0, what you do is you start the factoring process by using synthetic division. So take the 0 that you know. Again, this is a 0. It's not a factor, so you don't flip the sign. You only flip the sign if the factor is given to you. Line up your coefficients. And then use your synthetic division. So I'll bring down the 1. Negative 2 times 1 is negative 2. Negative 13 plus negative 2 is negative 15. Negative 2 times negative 15 is 30. 24 plus 30 is 54. Negative 2 times 54 is negative 108. And since that is a 0, we know that negative 2 is a 0. You better get 0 as your remainder. Okay? So now what we can do is we can start the factoring process. So I gave you the 0 of negative 2. What factor did negative 2 come from? Negative 2 came from the factor of what? Well, if x equals negative 2, what factor did this come from? Well, if I want to get 0 on one side, what would I do to both sides of this equation? I would do what? I would add 2. So there's your factor. Think about where the 0 comes from. You take a factor, you set it equal to 0, and you solve. So the factor that negative 2 came from is x plus 2 times. Now remember what we did with synthetic division last night for homework. These are your coefficients after you divide out that x plus 2. So remember, you have to drop this down a degree. So instead of starting with an x to the third, you're going to start with an x to the second. Minus 15x plus 54. So any questions on how I wrote the answer so far? Don't forget, they're asking you to factor. You can't leave off this x plus 2. That's part of your answer. Now notice this is a quadratic equation. Can you factor x squared minus 15x plus 54 any further? Are there factors of 54 that add together give you negative 15?
Yeah.
What are they?
6 and 9.
6 and 9. So x minus 6 times x minus 9 times x plus 2. All right? So once you get it down to this set of parentheses, guys, that's an x squared, you then go back and you use your other factoring process. Jay.
Sorry.
So any guys remember kind of doing this from last year a little bit?
Yes.
All right, let's take a look at another one. Shh. Grouping doesn't work. Because if I try grouping, and I factor a GCF out, I'm not going to get those parentheses to be the same. So this is where I'm going to use the 0 that's given. Remember, I'm going to set it on the outside. Again, you're going to start writing, this is where I'm getting that depressed equation from. Line up the coefficients, 1, negative 3, negative 16, negative 12. You guys go ahead and do that synthetic division for me. All right. So now, once you do your synthetic division, you can start writing this in factored form. So remember, what factor, don't forget about your 6. What factor did 6 come from? 6 came from the factor of what? X minus 6. Times. Now use these coefficients as the second polynomial in the next set of parentheses. You started with an x to the third, so you have to drop it down a degree. So that's going to be a 1x squared plus 3x plus 2. Now, can you factor x squared plus 3x plus 2 any further? Yes, it factors into x plus 2 times x plus 1. Okay? So any questions on, again, if you know 1, 0, then you can start that factoring process. All right, you guys go ahead and try. Now, which technique of factoring can I try on these 4 terms? Grouping. So let me go ahead and try grouping. Remember, you put parentheses around your first 2, parentheses around your last 2. What's the GCF I can factor out of the first set of parentheses? I can factor out of what? 4x squared. That'll leave me with an x plus 2. The only thing I can pull out of this x plus 2 is a 1. So my final factored answer is going to be x minus 2 times x plus 2 times 4x squared plus 1. All right. So any questions, guys, on C? So like I said, guys, once you get it down to this equation, if you have 4 terms, try that grouping. All right. Any questions on, if you know a 0, how you can actually get the equations into factored form? So if you can factor, ladies and gentlemen, you can find the zeros. Because once I get it in factored form, guys, how would I have found the zeros? I simply would have just taken each factor and done what with them? Set them equal to what? 0. So the next step is being able to solve the equations now that you can factor them. So given 1 0, find the other zeros or roots. Well, first of all, what's the maximum number of solutions this equation is going to have? What's the maximum number? Well, what's the degree of this polynomial? The degree is what? What's the degree? What's the largest, guys, shh, no. What's the degree? Shh. Guys, the only time you add the exponents together is if it's in factored form. Is this in factored form? No. You just look at the largest exponent for the variable. The largest exponent is 3. Guys, shh. So the maximum number of solutions is only going to be 3. You only add those together if it's factored form. All right? So I know that I'm not going to have any more than 3 solutions. It's always a good idea when I ask you to solve an equation to know how many solutions am I possibly going to have. So that's where you look at the degree. So now I can take the 5. You need to first get it in a factored form. So you have to factor it first before you can find the zeros. So just like we did a few minutes ago, I'm giving you the 0 of 5 so that I can line up my synthetic division, the 4, -9, -49, and -30. Bring down my first coefficient, so that's my 4. 5 times 4 is 20. -9 plus 20 is 11. 5 times 11 is 55. I end up with a 6, and then 6 times 5 is 30. That gives me a remainder of 0. So now when I start the factoring process, what factor did 5 come from? 5 came from the factor of what? X minus 5. Drop it down a degree. That's going to give me a 4x squared plus 11x plus 6. So now you guys go ahead and factor 4x squared plus 11x plus 6 for me, either using that X method, the Nike method, just do it, or whatever method you use. Did everybody get it factored into this form? So you have to include, guys, don't forget to include that x minus 5, the 0 that I gave you. X plus 2 times 4x plus 3. All right? Any questions on how I got it factored? Does that answer the question, guys? No. What's the question asking you for? It's not asking you for factors. It's asking you for what? The zeros. So now remember, this is where you just simply set each factor equal to 0. So by x equals 5, don't forget to include the 5. I've got -2 and -3/4. Guys, I cannot emphasize this enough because this got you on the last factoring quiz. If I ask you to factor, you leave it in the parenthesis form. If I ask you to solve or give me the zeros, that's when you don't solve everything. So make sure you understand the difference between a factor versus a 0. All right, so any questions on A? You guys go ahead and try and do B for me. Go ahead and factor it and then find the zeros for me. Don't forget, don't immediately jump and think you have to use the synthetic division to start. What method of factoring, before I can jump to synthetic division, what method of factoring could I try to do on this that you already know? You got 4 terms. Grouping. So don't forget to always check with something you already know. See if grouping works. So what GCF can I factor out of the first set of parentheses? I can factor out a what? 2x squared. And that's going to leave me with an x minus 2. What's the GCF I can pull out of x minus 2? I can pull out a what? 1. So notice grouping is going to work, so I won't even need to use my synthetic division. So when I factor it, that's going to give me a 2x squared plus 1 times x minus 2. Now notice the directions. Are the directions asking me to find all zeros or just the real ones? Real. So I don't need to worry about finding imaginaries. All right, so I can take my 2x squared plus 1, set it equal to 0, take x minus 2, set it equal to 0. Well, I know that 1 0 is going to be x equals 2. How am I going to solve 2x squared plus 1 equals 0? What's going to be the first step? Subtract 1. Then what? Divide by 2. Now, how do I get rid of the square? What do I do to both sides? I'm going to take the what? Square root. Is the square root of -1/2 going to be a real or an imaginary? Imaginary. So do I need to worry about going any further? No, because the directions are just asking you for reals. So you only have one real solution, which is x equals 2. So don't forget, guys, to check to see if you can factor using some of your old techniques. All right? So any questions on that one? So take a look at B. Kind of look ahead. Would grouping work on this one? No, because if I try and do a GCF out of the first set and second set of parentheses, those parentheses don't match. So this is where I'm going to have to, again, unfortunately, I'm not giving you a 0. So if this is a no calculator question, This is where you have to make your list of potential rational zeros. That's that P over Q test we talked about a few minutes ago. So again, the P over Q test. Remember, P are the factors of the constant. What is your constant term? Your constant term is what? -4. What are your factors of -4? Your factors of -4 are what? Plus or minus what? What two numbers multiply together give you 4? Give me a pair. 2 and 2. So I don't have to list 2 twice, just 2. Plus or minus 1, plus or minus 4. Now, what's your Q? What is the leading coefficient? The leading coefficient is what? 1. So all these divided by 1. Obviously, I know they're just going to be the whole numbers 2, 1, and 4. I need to know 1, 0. So from this list, I can use synthetic division to help me test to see which one of these numbers is a 0. So when I pick eeny, meeny, miny, mo, pick a number from this list, which one do you want to try? I always like to try the ones and the negative ones. So let me go ahead and try -1. So pick any one of these numbers from your list, do your synthetic division. How will I know if -1 is actually a 0? What has to happen with the remainder? The remainder has to be what? 0. So again, I'll line this up. I've got 1, 6, 6, -4. -1 times 1 is -1. -1 times 5 is -5. 6 plus -5 is 1. So is -1 going to be a factor? No. So I know that one's out. Try -2. I have a feeling -2 is going to work. 1, 6, 6, -4. Bring down the 1. -2 times 1 is -2. 6 plus -2 is 4. -2 times 4 is -8. 6 plus -8 is -2. And look at that. That one works. The list. Shh, guys. Shh. Jackson, turn around, please.
You could pick positive or negative.
Yep.
Okay.
Well, you could have tried plus or minus 1. You could have tried plus or minus
So you
4.
could try any one.
Any one of them.
Oh, okay.
Hopefully you get lucky and you pick one early in the list.
Okay.
So any questions on why -2 is a 0? So now we can start the factoring process. Remember, what factor did -2 come from? -2 came from the factor of what? X plus 2. Remember, these are the coefficients of your answer. Remember, we started with an x to the third. We have to drop it down a degree. So that's going to be an x squared plus 4x minus 2. So can I factor x squared plus 4x minus 2 any further? No. So I have to then think about other techniques of solving quadratic equations that I can use. I could use quadratic formula, or what did we go over in the last unit? You can try what? Completing the square. So I'm going to add 2 to both sides. So remember, to complete the square, I take the number in front of x, which is 4, divide it by 2, and square it. So what number can I add to both sides of this equation? I can add a what? When I complete the square, what number do I add to both sides? 4. So that's going to give me a 6 on the right. I can factor x squared plus 4x plus 4 into x plus 2 squared. Now what do I do to both sides? I can take the what? Take the square root. So x plus 2 is equal to plus or minus square root 6. So what's x going to be equal to? X equals what? -2 plus or minus square root 6. Are these real? They're real. Because the only way, real numbers are everything. Irrational, rational, the only thing that does not make a real solution is if you end up with a negative underneath the radical, then you have imaginaries. What's another solutions besides -2 plus or minus square root 6? Don't forget your other factor. Your other one's going to be what? X equals -2. How many solutions do you have sitting there? How many solutions are here? 3. What's the degree? 3. Did I find them all?
Yes.
Yes. Okay. You guys go ahead and try C on your own.